Welcome back. We are still going to finish up Unit 10, Day 2, areas of composite figures. We've already practiced a few where we've divided shapes into rectangles and semicircles or half circles. 2 trapezoids. Sometimes it's kind of weird to identify those. We looked at when you have to take some parts away, subtracting pieces that are not shaded. And then again, here's another rectangle and half circle. We talked about trying to find the minimum number of shapes you could. I could have divided this into 4 different triangles, okay? But it's easier on this to just find the area of just 2 triangles rather than 4 smaller triangles, okay? And now we have 2 left. We have this shape here and this green shape down here. So let's start with this gray shape here, okay? This one, hopefully this makes sense to divide this into a triangle and a rectangle, or we could call this a square because all 4 of my sides are the same and I have my 90-degree angle. So I know since the 4 sides are the same, opposite sides are both congruent. It is a parallelogram. So opposite angles have to be congruent. So these both have to be 90, which means these both have to be 90. So I can prove that this is indeed a square. Okay, so I have a square and I have a triangle. So if I look at my triangle, we've already looked at our formula chart for triangle, but we could open it back up if we'd like to, and we see that a triangle is 1/2 base times height that have to come together at a 90-degree angle. Okay, 1/2 base times height. And then my square when I look at my formula chart, I don't see a square. But remember, a square is a rhombus. I could do 1/2 diagonal, 1 diagonal, 2, but they didn't give me diagonal information, so I don't want to use that one. A square is also a parallelogram, so I can use my parallelogram formula, base times height. So base times height. All right, let's start with the triangle. 1/2 the base times the height. Now, if I look at this triangle, I don't see any 90-degree angles in the triangle, okay? I do know that this side here is definitely 22 units because all the sides of the square are 22. So if I can come 90 degrees to this 22 from the opposite side, that could be a height if my triangle is turned, if I turn my head to the left, right? So this is a height and this is a base. So how long is this piece? Okay, well, if all the sides of this piece here are 22, then that means this is 22. And if all of this is 42, then that whole length 42 minus the 22 that I've already used here means that from here to here must be 20. So this is 20. My base here is 22. My height is 20. And this I can do in the calculator. 1/2 times 22, 11, times 20 is 220. Okay, my square. The square is base, which we know is 22. The height we know is also 22. So 22 times 22, or 22 squared, because it's a square, is 484. So then to find the total area, all I need to do is add my triangle to my square. So my total area is going to be 220 plus 484, which is 704. My units here are centimeters, and since it's area, we say they are square centimeters. Remember that square never goes on the number, it always goes on the units. Okay, all right, let's look at the last one. This last one kind of looks kind of weird. It kind of looks like an old-fashioned little baby carriage to me, but whatever it looks like to you. Remember, we want to see what is the smallest number of shapes we can make. Okay, so when I divide this, I'm going to first say, well, I've got part of a circle here, right? I can see that that's part of a circle if I close this off here. And then it would be tempting maybe to draw a line here and say, okay, That's a weird shape. We'll deal with that in a minute. Okay, maybe not there. What if we draw a line here? It might be tempting to come from here and go up like this and say, okay, I got a triangle there that I can deal with that has a height of 2. And then I'd have to figure out what this base here is, but I know this piece is 4, so maybe I could figure something out there. And then I could come here like this and say, okay, there's a triangle that matches that triangle actually, and a rectangle. But that's a lot of pieces, 1, 2, 3, 4 pieces that I'd have to do together. So let's back up a little bit and say, wait, let's just look at these 2 pieces. I know that is 1/4 of going all the way around a circle, right? Because 90, 90, 90, 90. This is 1/4 of a circle. And then this down here, that, look at the shape. That's a trapezoid. So really, I have 1/4 of a circle. And then I have a trapezoid. And I just need to add them together. So let's start with our circle. I know I want 1/4 of a circle, and my circle is pi r squared, and I want 1/4 of that. So 1/4 pi r squared. 1/4 pi. My radius is 4. So that's going to be 1/4 pi times 4 is 16. 1/4 of that is 4 pi. Okay. If you're not sure, remember to use your calculator, right? 4 squared is 16. Then I'm going to do 1/4 of that 16 is 4. So 4 pi. I never put the pi in the calculator, so I still have to write it here. Now let's look at the trapezoid. If we forgot our trapezoid formula, we have our formula chart. 1/2 my 2 bases added together times my height. 1/2 my 2 bases added together times my height. 1/2 base 1 plus base 2 times the height. So that's going to be 1/2. Let's find our 2 bases. So one base is 4 units long, plus the other base. So I need to figure out how long is this whole piece here. Well, if I look down these little dotted lines, I can see that whole piece is 9. Okay, so I know that whole piece is 9 units long. And then how tall is it? It tells me that information also. It has a height of 2. So that's going to be half of 13 times 2. Now this 1/2 and this 2 cancel out. I know that's going to be 13. But let's do it in the calculator just to verify. 1/2 times 13 times 2 gives me 13. Okay. Now, when I go to add these together, I hit the bottom of the page. I can't scroll. I ran out of room. When I add these together, one has a pi, one doesn't. So this is my rounded answer. 4 pi plus 13 square centimeters. That is approximately equal to, if I put that in the calculator, 4 pi plus 13, rounded to 3 places. So 5, 6, 6. After the 6 is a 3, so I don't round it up. So it's 25.566. 25.566, and these are square centimeters. That is my rounded approximate answer. Okay? All right, so hopefully these practice problems gave you some insight on dividing your figures into as few shapes as possible, right? There's lots of shapes you could divide them into, and then you'd have to find areas for each one of those shapes. But the fewer shapes you can divide your pictures into, the fewer formulas you have to apply. Hopefully this helps. If you have any questions, please make sure you're asking during class time, either if you're in person in class or if you are remotely learning, then from home. Thank you so much for watching, and I'll see you in the next video.